Rules and rates of change. If you remember back to what we talked about Friday, what did a derivative mean, or what was the meaning of a derivative, or what did it symbolize?
Differentiation.
A derivative.
What was the question?
What does a derivative?
A continuous graph.
A derivative is a slope
Of
a tangent line to a graph at a specific point. So a derivative is the slope of the tangent line. You've got to get that down. So that is one thing I'm probably going to ask you every day so that we understand it's the slope of a tangent line. So now real quick, the derivative of a constant function is 0. So you should have found that on your assignment when you found, I think the first one might have been h of x equals 3. When you go through and calculate that, you should have gotten that to be 0. So every constant function, the derivative is 0. Now don't think you can go just write that in. I mean, I'm actually checking your work on these, so I'm not just checking your answer. Okay? But that's what the derivative of any constant is. And so now Ross kind of already alluded to this yesterday, or Friday. And so if I was given this, x squared, back to Friday, Ross, since you kind of spilled the beans, what was the derivative of x squared? You remember that, what you said? Close.
Yeah.
2x. What was the derivative of x cubed? 3x 3x squared. What was the derivative of x to the 4th? 4x cubed. Let's do one more, and then maybe the rest of us will catch on. What is x to the 5th? 5x to the 4th. So let's talk about where that comes from. Where does that come from? How do you get that?
It's kind of like the things last year when we had like 20 same questions like this. And each kind of
You take the 5 and what do?
In the front.
Move it in the front, and then you subtract 1 from the exponent. So you take the 4, move it around front, subtract 1 from the exponent. Take the 3, move it around front, subtract 1 from the exponent. So that's what it is here. Okay, so if you look at that, that is written in general. You take the exponent, you move it around front, subtract 1. So, got it? So now let's go ahead and look at some of those. All right. Now obviously I'm not going to start with an easy one, okay, because I think you can handle the easy ones. We're going to start with this one. So the very first thing you need to do is you need to rewrite that. So what would that be? X to what power?
1/3.
The 1/3. So then now to find the derivative, we're going to take the 1/3 and what are we going to do? Move it to the front. So really I've now got 1/3 x to the what power? Subtract 1. So let's just do it this way. One-third x to the negative 2/3. Good. Now, you know I won't let you answer negatives. So it's going to be 1 over 3x to the 2/3. Okay? So with that in mind, I want you to look at this one. And I will tell you right now, the answer is not 1 over 2x. What did we do on the previous slide?
Flip the book.
You rewrote it, right? Let's rewrite it so that it's x to a given power. So how can I write 1 over x squared as x to a given power?
Negative x to 3.
Negative 2. Okay, so now let's do the rule. What do you get?
Yes.
Careful. Negative 2x to the negative 2x to the negative third. A lot of people think it's actually negative 1. It's not, because it's basically negative 2 and negative 1, which is negative 3. So your final answer then will be negative 2 over x cubed. So when you have them in the denominator, you're going to have to rewrite. And so what I have down here for you, okay, is some steps, because on your homework it asks you to rewrite and it asks you to go through these certain steps. So this is what they mean. Here's your given problem, right? They ask you now to rewrite it, which is what we did. Then they ask you to differentiate, which is what we did. Then they ask you to simplify. So we did all of those steps. They ask, and so what they're going to say is they're going to say like, find the derivative by rewriting, differentiating, and simplifying. Well, here's what we did, okay? Step 1, rewriting, was right here. There's your rewrite, okay? Then differentiate. Then simplify. So see, we did all 3 of those. We just didn't identify what they were. Okay, so on your homework, you're not going to need to say rewrite this, differentiate this, simplify this. Just do the 3 steps I did here and you're fine. Okay? That is how you must do those ones with powers in the denominator. No. Okay, so let's look at this one. What am I going to do now? The very first step, should we do? Let's rewrite it. So, what would be a good way to rewrite this? 4/5 times t squared. Okay. Separate. Yes, it is. The exact same thing. So then now, what would your answer be? What would your answer be?
I know.
8/5 t. Now, if you're wondering, remember we take our 2 around front. So I take 2 times 4/5, which is 8/5. Subtract 1 from 2, and you get 1. What about this next one? It's the very first thing you do.
Rewrite.
Yep, so
2 to x 1/2. Oh yeah.
good, there you go. What's your next one going to be? What'd you say? Yep, bring the 1/2 front. So what do I get then? X to b. Now, if you guys are wondering, remember we take our x to our 1/2, bring it around front. 1/2 times 2 is just 1. Subtract 1 from 1/2, you get x to the negative 1/2, but we don't accept that. So I get 1 over x to the 1/2. Now, normally, you know my policy. I do not let square roots go in the denominator. I will let them go for this.
Okay, now your policy is getting screwed.
Because this, I'm more concerned that you can find the derivative than I am concerned that you can simplify. We've already focused on simplifying. So, all right. This one, let's look at this one. Then we've got 2 more slides to go through. Okay. Very first thing, we need to rewrite. Okay. Remember where I said you cannot have a variable.
So is it 1 over
Yep, you could write it that way. If you want to, let's start with that then. Okay, if you didn't catch what Christine just said, this is what she just said. Now remember, we cannot find the derivative when it's the variables in the denominator, so I need to rewrite that again. So it's 1/2 x to what power? Negative 2/3. So now, what I need to do is what? Move the negative 2/3 around front. So what is negative 2/3 times 1/2? So negative 2/3, here we go, times 1/2, folks. Yep, you get negative 1/3 x to the negative 2/3 and negative 1. What do you get? Negative 5/3. The easy way to do that is to just add, instead of subtracting 1, subtract 3/3. Kind of do that in your head. So negative 2/3 and negative 3/3 is negative 5/3. And so your answer will be negative 1 over, oh, that's a good 3. 3x to the 5/3. So now if I remember right, on this next slide, I think we're going to have constants. Okay, close. We'll come back to that one tomorrow and those tomorrow. This is where I want to finish today. Okay, I want you to just look at those, and without like stress, I want you to tell me, what do you think the derivative would be of this top one? 3x what? Squared minus 4 plus 0. Now, this is the thing. This is x to the first, right? You bring the 1 around front, and then you subtract 1 from it, so it's really like x to the 0 power. Remember, it's always 1 less. The power is always 1 less than what you're given. So really, your answer is just 3x squared minus 4. So when they combine them, all you do is put the same sign between them and find the derivative of each individual term. The 0, remember, the derivative of any constant is 0. Okay, so let's go through this next one. So now there are two ways to do this. One, let's just bring the 4 around front. So really now, I have negative 4x cubed over 2, right? Plus what?
Zero.
Minus 2. Because it's always 1 less. Remember, your derivative always is 1 power less. So now the only thing I need to do is simplify this to negative 2x cubed plus 9x squared minus 2. So when you have a quantity, that is what you do. Now, I'm going to go ahead and give you your assignment. Now, this is your assignment. Okay, page 115, 3 through 34, 39 through 51. We will actually finish this tomorrow. Okay, 39 through 51, the odds, 3 through 34, all. Okay, so we will finish this section tomorrow. We'll get through those slides we didn't quite get through. You should be able to get a good start on it, though.